Hello everyone, I am Abhishek HR. Welcome back to the online session on Dynamics of Machines. In the previous session, we were learnt about the procedure to solve the slider crank mechanism problem. So in that, we have seen the different steps that we have to carry out to find the different forces acting on the each link as well as the torque acting on the link. In today's session, we are going to solve one problem on slider crank mechanism. So this is the first problem under slider crank mechanism. A slider crank mechanism is shown in the figure. So it is the given figure. The force applied to the piston is 1000 Newton. The force applied to the piston is 1000 Newton when the crank is at 60 degree. When the crank is at 60 degree from the IDC, inner dead center. Calculate the driving torque T2. We need to calculate the torque T2 on link 2. So it is the given figure, means a rough figure that is given in the problem itself. And they have also given the distances of the link, that is AB is 100 mm and BC is 300 mm. So using this hint, we need to construct the slider crank mechanism once again, because it is the given figure in the problem, means a rough figure. So while solving analyzing the slider crank mechanism, the very first step is we need to construct the mechanism. So let us construct the mechanism first. So this is the step 1, construction of the slider crank mechanism. So now use your scale and use the distances values, but this is in mm, 100 mm and 300 mm. So you need to convert those distance values into the required proper scale. So here I will consider as 1 centimeter is equal to 40 mm. 1 centimeter is equal to 40 mm. So it will become, so if I do 100 by 40, it will 2.5 centimeter, and if it is 300 by 40 means it is 7.5 centimeter. Now with respect to this scale, we have to construct the slider crank mechanism. So here we know the angle also, that is 60 degree. AB, this is the point A. AB, that means the link 2 is at 60 degree with respect to the first link. So just draw a point or mark a point, and so this will be your link 1. So use your protractor and put your protractor at the point A, means that is the link 1. So here measure the 60 degree and mark it and draw a line of, what is the value of AB? 100 mm. 100 mm means it is 2.5 centimeter. Draw a line of 2.5 centimeter. So this is B. Here torque T2 is acting. So this is the AB, that is the link to 100 mm. The converted scale is 2.5 centimeter. Now we don't know the AC value, means the link 1 distance value. Just draw a straight line . Just draw a straight line. Then we know the distance of BC, that is 300 by 40. that is 7.5 centimeter. Now use your compass and measure the 7.5 centimeter on your scale and put your compass on point B, cut an arc. From B, at point B, use your compass, measure the distance of 7.5 centimeter and cut an arc and mark this point and join this BC line. So this is C. This is link 2 and this is link 3. This is link 1. So this is A and B is 2.5 centimeter, that means the 100 mm, and B and C is 300 mm, that is the 7.5 centimeter. Now we have completed the construction of slider crank mechanism. I will repeat the step once again. Mark a point, that means the fixed link 1, and use your protractor, measure the 60-degree angle, then use the distance 2.5 centimeter with respect to the link 1, the point which have been marked. So with respect to that, draw a straight line of 2.5 centimeter, then use your compass and put your compass on point B and cut an arc with respect to the straight line and you will get a meeting point. So connect that line, that is the BC, so that it will complete the construction of slider crank mechanism. Now we have one more parameter, that is the load, that is the load acting on the piston, that is how much? 1000 Newton. So at point C, means that is the link 4. This is link 4 now. So here the load is P, that is 1000 Newton. 1000 Newton. Now the construction of the slider crank mechanism is completed. What is the next step? So now we have to draw the free body diagrams of the mechanism. Step 2 is draw the free body diagrams. Free body diagram. So we have the link 2, link 3 as well as the link 4. Just draw it and mention the forces acting on the link. A, B, here it is T2, that is torque, and a line BC is attached with link 2. So this is the force F32. The force of link 3 is exerting on the link 2. So it is F32 and it is F12 as per the two force member condition. Now we have BC. Draw a line parallel to BC, BC, and the forces acting on the link 3 is F23, here it is F43, F43, this is link 3, this is link 2. Okay, now we have the link 4. So in the link 4, we have three forces acting at a point, that is a collinear, and here it is F34, and this is the load, actual load P is equal to 1000 Newton, and this is F14. F14. Why? Because here the link 3 is meeting at the link 4 as well as the load also, and also we have one more force, that is F14. Now we have completed the second step, free body diagram of the slider crank mechanism, the mechanism what we have constructed now. Now we will move on to the next step. Step 3. See, I will tell you one more thing. Here I don't have much space, so I will just continue in the next column. But while you constructing in your page, start the mechanism at the top side of your page, and you have to complete the entire problem in that single page only. Don't start the problem with half page. So start the problem with the full page and draw your mechanism at the top side of the page, so that it is easy to take the parallel line of the mechanism. So here step 3, analyze the forces. Analyze the forces acting on the links. Acting on the links. So here the BC line, I will draw it once again, BC, link 3, and here we know the forces F23 as well as F32, here F34 as well as F43 also, isn't it? Now, so to find the forces, we need to construct the polygon. Construct the polygon. How we are going to construct the polygon? Use the load value, the load acting on the piston. How much it is? 1000 Newton. So using that value, we can construct the polygon, so that from the polygon we can calculate the forces acting on the links. So here I will convert this load value into the proper scale, so that it is easy to construct the polygon. So scale will be 1 centimeter is equal to 100 Newton. 1 centimeter is equal to 100 Newton. So here I have 1000 Newton. So 1000 Newton divided by 100 means it will become 10 centimeter. So draw a line of 10 centimeter parallel to the load acting in the direction, that is the x-axis. So draw a straight line from right hand to the left hand side, because the load is acting on the mechanism is from right hand side to left hand side. So draw a line of 10 centimeter. OA. So this is the straight line that I have drawn now. 1000 Newton has been converted to the required scale, so it will become 10 centimeter. Now parallel to the load acting on the mechanism, so I have drawn a 10 centimeter line in the x-axis. Now from A we should draw a line, straight line, parallel to the BC, exact BC line. So in your notebook, take your scale, put your scale on the BC that you have constructed in slider crank mechanism, and move your scale to the point A. Just draw a straight line. Just draw a straight line. because we don't know the exact value. So I have just draw a straight line parallel to BC. Now I have a perpendicular force with respect to load acting. So that is F14. Just draw a line here. So you will get a meeting point here, that is point B. It is point B. So mention here P is equal to 1000 Newton and AB. Measure the distance of AB. Measure the distance of AB. So you will get the distance into the scale. The distance, you have to measure the distance in your scale, and that answer must be multiplied with the taken scale, that is the 100 Newton. So if you measure and multiply with the scale, that is 100 Newton, means you will get 1050 Newton. 1050 Newton. Measure the distance from A and B. A and B. So that measured value has to be multiplied with the taken scale, that is the 100 Newton. So you will get the answer AB is equal to 1050 Newton. Sometimes we will get 1049 also. It is not wrong. It is also correct. Don't worry about that. So almost you will get 1049 or 1050 only. Now in the same way, measure the distance of OB. So OB is equal to the distance value into scale. So OB is equal to 300 Newton. OB is equal to 300 Newton. It is also same like the AB value. Measure the distance of OB, multiply with the scale. So you will get OB as 300 Newton. Now we know the value of AB, that is 1050 Newton. What is that 1050 Newton? That is nothing but the forces acting on the BC, that is F23, F32, which means the magnitude of the two forces must be same but in the opposite direction. So the forces value will become F23 is equal to F32 is equal to F34 is equal to F43 is equal to 1050 Newton. 1050 Newton. Now we have analyzed the forces acting on the link. Now the last step in the problem, that is we need to calculate the torque. So now the last step is we need to find the torque applied on the link too. So calculate the torque T2. Now here you have to construct the link 2 one more time. Once again you have to construct the link 2 with respect to the angle 60 degree. So draw a point, make a point and put your protractor, measure the 60 degree, the AB length, how much it is? 100 mm. The converted scale is 2.5 centimeter. So with respect to 60 degree, draw a line of 2.5 centimeter. So it is A and this point is B. Here it is T2. Now for the link T2, we have a parallel line attached, that is BC as well as the link 1. So just show it here, a parallel line means the two forces acting on the opposite direction. Now here just put a point, just make a point here, and at this point use your protractor, measure the 90 degree angle, because don't draw a rough straight line because it will not give the correct height value. So first measure the 90 degree distance, then draw a straight line. So this is the 90 degree. Now measure this distance, that is nothing but the height. Measure this distance. So when you are going to measure this, you will get torque is equal to force into height. So that is your F32 or F43. What is the value? 1050 Newton. 1050 into height, you will get around 94 or 95 mm. So take it in meter or millimeter. So I will consider in meter, 0.095 meter. So the T2 value will be 99.75 Newton meter. Newton meter. So this is the required torque that we have calculated acting on the link 2. So here I will repeat the step once again of the step 4. Once again we have to construct the link AB, that is the link 2, with respect to the converted scale, and with respect to the link 1, we have to measure the 60 degree angle, and for that we need to construct the 2.5 centimeter line, that is the AB distance. Now just show the opposite direction, means the forces acting on the A and B, and for the extended line, on the extended line, whether top side or the bottom side, just mark a point. At that point, use your protractor, put your protractor at that point, measure the 90 degree and draw a straight line. Then in your scale, measure this distance, that is the height of the link. So you will get around 94 or 95 mm. So convert into meter or keep it in mm also, no issue. So the torque formula, that is the force into the perpendicular distance. So force is here F32, F23 or F34, anything. So we will get 1050 Newton that we have calculated here. Now the distance, that is 0.095 meter, that is the height we have measured now. So if we multiply this, we will get torque T2 as 99.75 meter. So this is how we are going to analyze the slider crank mechanism. I will repeat the step once again. See, the very first step is construction of the slider crank mechanism, which means we need to construct the actual mechanism as per the given problem statement. So in the problem statement, they have given the dimensions, means the distance of A and B, B and C, as well as the theta, that is 60 degree. So with respect to that, we have to construct the slider crank mechanism. So here, first while constructing the mechanism, we need to mark a point first. With respect to that point, just draw a straight line in x-axis. Just draw a straight line. So then at point A, measure the 60 degree angle, because it is clearly mentioned that the link 2, that is AB, is positioned at 60 degree. So use your protractor, put your protractor on point A, measure 60 degree, and the AB distance, how much it is? 100 mm. So 100 mm means that for the converted scale it will be 2.5 centimeter. So draw a 2.5 centimeter line at 60 degree. At 60 degree. Okay. Now after constructing the AB link, then use your compass. You know the value of B and C, that is 7.5 centimeter. Measure the 7.5 centimeter distance on your scale and put your compass on point B. Just cut an arc of 7.5 centimeter that you have initially drawn the straight line. So there you will get a meeting point and just join the line BC. So your slider crank mechanism will be completed. Now on the link 4 you have one more force, that is the load acting on the piston, that is P is equal to 1000 Newton. Show that force also, so that will complete your slider crank mechanism construction. In the second step we need to draw the free body diagram of the slider crank mechanism. Here I have drawn the free body diagrams, that is link 2, link 3 and the link 4 also. How we have to draw and how we are going to consider the forces, that I have already explained in the procedure in the previous video, that I have explained about how to analyze or how to solve the problem on slider crank mechanism. So based on that I have drawn the free body diagram in the second step. Now in the third step we need to analyze the forces acting on the link, on each link. So to calculate the forces I have to construct the polygon. To construct the polygon I have a hint here, that is the link 4. Why I have selected the link 4 means, because here 3 forces are acting at a point. Among those 3 forces I know the force value which is acting on the piston, that is the P 1000 Newton acting on the piston in the x axis. So with respect to that I will convert that into the required scale and I will draw a straight line of 1000 Newton in the x axis from right hand side to left hand side, parallel to the P, the load P acting on the mechanism. So from that I will get a straight line. Then at point A I have the one more link, that is F34, that is BC. So parallel to that draw a straight line, because we don't know the magnitude of that link, I mean the distance. So just draw a straight line. And we have one more force, F14, that is acting perpendicular to the acting load. So just draw a perpendicular line from A. So you will get a mating point here. So that will be name it as a B. So O, A, B represents the complete polygon. So this, the magnitude of OA is known, that is 1000 Newton. Now measure this distance A and B. So when you are going to measure that distance A and B, multiply with the taken scale into 100 Newton. So we will get AB as 1050 Newton. This is nothing but F32 or F23. Now measure the O and B. So when you are going to measure O and B, multiply with the required scale. So we will get OB is equal to 300 Newton. Now we know that the two force member condition, that means the forces acting on a body have the same magnitude but in the opposite direction. So F23, F32, F34, F43 is equal to 1050 Newton. See, this is very, very important. After finding out the distance of AB and OB, you must write this, or you must show this: F23 is equal to F32 is equal to F34 is equal to F34, F43 is equal to 1050 Newton. So this is how we are going to analyze the forces on the link. Next, after this, while coming to the last step, once again we have to construct the link 2. So we know the construction of link 2. So using the 60 degree, we can construct the link 2. Then we have to show the opposite direction of the forces acting on the link. Then just extend that line, and on that extending line mark a point at center and use your protractor, measure the 90 degree angle and just draw a straight line. I will repeat once again, don't draw simply a straight line. Measure the 90 degree and then draw a straight line. Otherwise you will not get the correct height value. You will get the same link value as of the AB, because when it is reconstructing the link, and when you are going to measure the 90 degree and then you will draw a straight line, you will get a different height. So that height is nothing but h. So you will get around 95 mm or 94 mm. So then we know the formula, that is torque is equal to F32, means the force into the distance. That is how much here? 1050 into 0.095. So we'll get torque as 99.75 Newton meter. So here why I have taken the F32 means because on the link 2 we have the forces, that is F32 or F23. So here I have F12. So if anything I consider F12, F23 or F32. So it is the 1050 Newton. So it is 1050 into 0.095 meter. So it will give 99.75 Newton meter. This is how we are going to solve or we are going to analyze the slider crank mechanism problem.